Welcome, everyone. My name is Dan O'Sullivan, and I'm Vice Chair at the MIT Enterprise Forum, New York City. Welcome to tonight's event. Thank you for attending. We appreciate it. And I'd like to first say a few words about the MIT Enterprise Forum and its mission. We are a nonprofit. We have about 10 chapters throughout the United States and a little under 10 internationally. We regularly host workshops and expert panels and fireside chats on a range of subjects from artificial intelligence to cloud computing to cities of the future to biotech, energy, and of course tonight's topic, which is 5G and telecommunications. So we generally charge per event, but we also have an annual membership. If you're interested, you can go to mitefnyc.org and sign up there. And for a nominal charge, I think it's about $100, you get to attend all events throughout the year. So, okay, with that, let me introduce tonight's event and our distinguished panelists. Tonight, we're going to be talking about 5G and its implications. And we have the honor of having Thomas Marzetta, PhD professor at NYU Tandon School of Engineering. Tom has worked at Bell Labs, and he is the lead author of the book Fundamentals of Massive MIMO, multiple out networks. So Professor Marzetta was on the board, the advisory board of MEMOET, that's Massive MIMO for Efficient Transmission, an EU-sponsored FP7 project. He was coordinator of the Green Touch Consortium's large-scale antenna systems project. And recognition for his contributions to Massive MIMO include the 2017 IEEE Communication Society Industrial Innovation Award, the 2015 IEEE Stephen O. Rice Prize, and the 2015 IEEE WRG Baker Award. He was elected a fellow of the IEEE in 2003 and received an honorary doctorate from Linköping University in 2015. So with that, let me just turn it over to Tom to allow him to say a few words and introduce himself further, and then we'll get on with the session. Welcome, Tom. Oh, Tom, you're on mute.
Thank you, Dan, for having me in this forum. It's a real honor, and I hope that we have some very nice questions from the audience. So I'm Tom Marzetta. Background: when I was a boy, my father was an electrical engineer at National Bureau of Standards, which is now NIST, of course. Early on, he taught me Morse code, how to solder, helped me build a crystal radio. I think when I was just starting high school, I got an amateur radio license. My father always wanted me to be a physician, a doctor, but I couldn't get very interested in the subject. I started college wanting to be a chemist, then a physicist, and finally an electrical engineer. So one does these things by roundabout ways. I finished school in 1978, and I could have gone to Bell Labs at the time, but an even more fascinating offer came from the petroleum exploration industry, which at the time was in one of its booms. I went to work for the French company Schlumberger, an oil field services company. They were gearing up their research lab in Connecticut. It was a great time. People physicists, acousticians, mathematicians, professional people whom I had not worked with before. And I quickly learned how little I really knew. And so this was a great inspiration to learn some new things. So after 9 years in that industry, the industry, as it periodically does, it did a nosedive, and I elected to try my luck somewhere else. I went to the defense industry for 8 years. And then finally in 1995, went to Bell Labs, where I was there for 22 years until I moved to NYU just 3.5 years ago. So at Bell Labs, for the first time, I worked in wireless communications. I had not opened a book on communication theory since my school days. Some great opportunities came along at the time. Multiple antenna wireless was something just being discovered. The whole idea that without extra power or extra spectrum, you could increase throughput seemed like a magical thing. And so I got in on it early. It was the best thing that ever happened. And I managed to make some contributions. As Dan said, massive MIMO. I could talk a little bit about that later. Finally, 3 years ago, great opportunity to start a new career at NYU. So it's twists and turns, and I've worked in a lot of different things. Not the usual way to run a career, but it worked very well for me. So.
Very good. Great. Thank you for that. Sounds like a very storied career. And so let's, with that, dive into the session. I'll just read the little intro here. After years of hype about gigabit speeds, 5G finally became a reality in 2019. AT&T, Verizon, T-Mobile, and Qualcomm all now have some form of 5G service available. And you can buy 5G phones and take advantage of the higher speeds of those networks today. But while 3G made internet surfing possible on our smartphones and 4G allowed us to stream video in real time, what will this next generation of advanced communications bring us? And when will the day arrive when we can affordably leverage these services in our everyday quest for increased productivity and content consumption? So with that, let's dive in right away to find out. I mean, we've all heard the buzz and the marketing hype and so on. And, you know, it doesn't take a rocket scientist to figure that, you know, 4G was going to be better than 3G and 3G better than 2G. But 5G has some fundamental differences to it and some fundamental implications due to the fact that it's it's significantly different technology, but it's also arriving at a time when cloud computing and processing capability and cost and so on are all advancing rapidly. So with all that as a backdrop, let's go through a few topics. So Tom, first of all, could you give us a quick overview of 5G technology and the fundamental improvements over earlier models?
All right, so all of these new generations of wireless, and typically they occur every 10 years, entail new advances, usually that make the old equipment obsolete at the lowest level, the air interface, the physical layer. So the physical layer of a wireless system consists of what? Amplifiers, antennas, signal algorithms, modulation schemes, multiplexing schemes, the lowest level. This is actually a really, and usually when this comes about, or always in the past when this came about, it made the previous equipment totally obsolete. So the very first generation was analog telephony, wideband FM actually. And that, of course, was totally obsolete when second generation came along, which was digital. We went to third generation, CDMA. It made the previous digital versions obsolete, but we first started to get data with generation 3. Then we went to generation 4. Again, everything became obsolete because now we had something called OFDM, orthogonal frequency division multiplexing, which, by the way, was a great Bell Labs invention from the early 1980s. But going generation 4 to 5, we find that the old equipment still works, which seems like a peculiar thing. So the two physical layer innovations in the 5th generation. One is the introduction of millimeter wave frequencies, so roughly operating at 15 times the current carrier frequency. Every time you step up carrier frequency by a factor of 10, guess what? There's 10 times as much spectrum available. So this seems like a great thing, and inherently it is. But yeah, you can go buy a new handset, a new cell phone that can utilize millimeter waves. But if you keep your old one, it will just use the old mid-band spectrum, which is never going to be abandoned. It's too valuable. The other innovation for 5G at the physical layer is massive MIMO, which is instead of a 4G base station, which spews power indiscriminately over, say, 120 degrees of angle, massive MIMO has a very intelligent phased array, 64 separate low power, each individually controlled antennas. And in fact, this antenna array actually beams out beams of information selectively and simultaneously to many users at once. So all of the users get to share all of the time frequency resources, whereas 4G, the time frequency resources were chopped up, this part for this individual, this part for this individual, and so on. So massive MIMO is quite simply the most spectrally efficient wireless scheme yet devised. So this is the basis of it. But again, because of the desire for back compatibility, things haven't been taken as far as they could at the physical layer. That's one thing. The other thing is we haven't, you asked the right question. You said the previous generations brought us totally new service. So, you know, within the past 10 years, you've been able to stream video or even transmit video uplink. So far, we don't have any new transformative person-to-person communication scheme in sight. So that's an interesting fact. And yes, people talk about many applications, but there, so far as I can see, no one has identified a really, truly transformative application.
Yeah, so there's no sort of, so to speak, killer app for 5G as yet. Is that right?
That seems to be so. And is one going to emerge? Well, that, of course, it's a little difficult to predict the future, but just personally, I haven't seen anyone jumping out yet.
Yeah, yeah, and I can see where, you know, there's the basic economic benefit of we'll always take the faster speeds and we'll always want higher quality video and we'll always want to, you know, watch that on our mobile devices versus our desktop. And if we can carry that around, you know, and get sort of like Wi-Fi or Ethernet speeds over the cell network, we'll always take that. But I think at the same time, yeah, whereas 4G allowed, you know, streaming video, I think 5G is going to need something equivalent. And I have no doubt that'll come along. It's just that, yeah. But I guess this is the way networks evolve, network technologies evolve, right? You put in place the foundational infrastructure, you know, for the cell towers with the latest, you know, receiver and transmitter technology. You architect it in such a way that, as you say, it's spectrum efficient, and you know, there's a pretty good bet that the applications are going to show up at some point, you know. So and I mean, with that, for example, you know, one area that I've read a little on is IoT, for example, right? And what would be, for example, what could you do? And for the, I'm sure our audience is fairly familiar with both 5G and IoT, but for the benefit of those that are not, you know, the Internet of Things is, you know, just basically a network of of so many devices, from factory floors to medical devices to, sensors, and constantly feeding information back to, cloud computing resources, which then leverage the power of machine learning and artificial intelligence and so forth. But like, as just as a sort of take a reference point, what is it that you could do in IoT with 5G when it's fully implemented that you just couldn't do in 4G?
5G, I think, well, first of all, there is more spectrum available with the opening up of millimeter wave. That sure makes life easier, but we have to learn how to use millimeter wave spectrum. Still, we can do things with it, but its full potential hasn't been realized yet. And then there were various features at the higher layers which give you just flexibility in coding and resource allocation that probably undoubtedly will come in handy when you're actually trying to net together, tens of billions of these IoT sensors. That said, the question is, one good question is, what effect will IoT have on the average person? I mean, cellular telephony was certainly hugely transformative. Anytime I ride the subways in New York City, it seems like every other person, maybe 2 out of 3, are streaming video. So these have affected a lot of people one way or the other. IoT, it's not so easy. Yes, people talk about a smart home where every light switch is controllable remotely, everything linked together, doors and windows can open and close automatically. Or more, people even talk about how every single item that you own will eventually have a IoT tag. I mean, now, is this necessarily a good thing? Is this the most exciting vision of the future that engineers and scientists have to offer to the public? Not so obvious. Elder care. Now, if you can, of course, this is a huge problem, an aging population. The baby boomers are starting to show their age now, and there are a lot of them. And so can this sort of technology help these people function better? That would be a nice thing. Some of the things seem very fanciful. The idea that if you just put IoTs all over the city, that somehow you can solve the traffic problem. Well, anyone who ever has walked around Manhattan during rush hour knows that no matter how many sensors you throw at it and how sophisticated the control algorithms, you're still going to have traffic jams. There are just too many cars and unruly drivers for the street system. I'm skeptical that can easily be solved. The other thing the counter to all of this is issues of privacy, security, safety. I mean, do you really want every item that you own to have a tag? And so somewhere in the cloud, it's theoretically possible that anybody could just view every possession that you have. Do we want a world like that? So security is, and this is positively a safety issue. And if you think of how often your cell phone or your computer takes time out to upload a new operating system, what are you going to do when all the lights go out and in order to upload a new IoT operating system? So I've been a bit pessimistic here, but I think that we shouldn't go into this with unblinkered vision.
Yeah, I agree. And it kind of, as I'm listening to you, Tom, it reminds me of the analogy with social media and even like with professional networks and that, are they a good thing that everybody can go on LinkedIn and, you can upload your profile and you can network with like-minded individuals or look for work and look for opportunities? Absolutely. And in some cases, something like, the social networks like Twitter, Facebook, and so on, they do it, there's value, but there's also a downside. And so I think IoT in the same way, IoT and 5G, yeah, I mean, everything you said makes sense. I think there'll be huge privacy concerns about tagging everything, and I think people will want to, of course, opt out of that ability. But I think also there'll be some obvious advantages I can see fundamentally, let's say in shipping or in the supply chain, right? And where goods are and how they make it from one part of the globe to the other. And I think also with, as you alluded to there, the aging baby boomers, but not just that, but medical in general, where a doctor having, or let's say a doctor with a specific skill set, a very unique skill set, having immediate real-time access, not just through high def video, but maybe through, augmented reality, or essentially be able to be there. So I think there's going to be areas maybe that, will be obvious, great use cases. And then, like you say, there'll be areas where you're kind of struggling to fit a square peg in a round hole.
Just one point I wanted to make before we, I've said some negative things here and there, but the point is, just think over the past year, the communications system that links us all together has functioned amazingly well. How could we have a meeting like this without Zoom and all of the attendant bandwidth issues that go with it? It works amazingly well. I mean, I've been teaching classes for a year now remotely, and in fact, I've even used it to my advantage. The fact that my current class is remote means people from all over the world can take the class. So I, for instance, have a student from EPFL in Switzerland taking my class. So you can't do that with a live class. But again, we would have really been lost in the last year in terms of most of us doing our jobs. Farmers, of course, can survive without it, but many professionals simply could not have functioned without the amazing communications that we have. And that was something 4G brought us, and 5G is enhancing.
Absolutely. And, it's amazing how timely the evolution of, the network technologies and the availability of Zoom, as you say, at the time when it was absolutely needed the most, at the start of the pandemic, and that really kind of impressed me, that the architecture of the internet and the backbone, the fiber optic networks and so on, that it was all there, ready to be leveraged. We didn't have to go out and invent that when the pandemic hit, so it makes a great case for continued research in these fundamental topics, I think.
Well, and it also raises the very interesting question, what is the next level of human-to-human communication going to be? That's I think there is an answer to that, though it's a personal opinion not shared by all. I think ubiquitous augmented reality. I mean, Zoom, of course, is amazing. It's enabled us to carry on our business, but of course, we're all pretty sick of it by now and are longing for live meetings. Well, the next best thing to a live meeting would be augmented reality that's so good that the other person who's thousands of kilometers away seems to be in the same room with you.
Yeah.
And this is really, this is part of course, the emphasis of the research in the NYU Wireless Center, which is, if you look at what the projected wireless requirements are for any sort of mobile form of augmented reality, they're staggering. 2 or 3 gigabits per second per user, sustained throughput, latencies as short as 10 milliseconds. And so imagine if you got back to normal times and you have 20,000 people in Times Square, each with some sort of portable augmented reality device, wanting to link up with their comrades thousands of miles away. How are you going to give each of 20,000 people 3 gigabits per second? So there's no foreseeable 5G technology, even massive MIMO pushed as far as you can push it, that can deliver this sort of thing. So we actually do need renewed and very vigorous wireless research for this, because 10 years from now, people are going to say, well, what's 6G going to be about? And there'll be, I think, pent up demand for some totally new form of person to person communication.
Yeah, so that's a great topic you brought up. And so I'm curious, what do you reckon? How far off is something like you described in Times Square there? Or maybe not thousands, but with 5G at its best, when do you see augmented reality, across a decent span of geography being practical?
That's a good question. I don't know enough about the display devices and so on, what that state is. Something, it has to be, of course, very unobtrusive. Don't know what's being done there. So that's certainly going to be a bottleneck. But I've considered only this mobile wireless communications bottleneck. And sure, you can with these millimeter wave networks that are now being done, they've been tested in special cases of giving, 1.5 gigabits per second. But this, of course, is to a single user at a time who happens to be very well placed with respect to the millimeter wave base station. The idea of thousands of people simultaneously getting this experience, but we need real breakthroughs. And yeah.
Yeah, absolutely. And it's interesting too, to what extent, like I've had a few of the, Oculus and virtual, and augmented reality headsets on, and it is pretty amazing how it transports you there. And for example, if you like to go skiing or snowboarding, it's almost like, well, you don't get to do that, but maybe it kills the bug in you to go do that for a while. So I think it kind of, and the same thing, I could see that in business meetings, whereas, Zoom and so on, and Microsoft Teams have negated the need for, hopping on a plane and going face to face, hasn't taken it away. And as you say, I think that people are keen to get back to that person to person. But I think, there's a market for it, and there'll be a change, but I don't think it's going to be like everybody's going to want to jump on the AR and VR, bandwagon and I hope not, at least, and do away with person-to-person meetings.
Well, yes, that's, I myself sometimes leave my cell phone behind by accident, and it's actually gives one a sense of freedom to be alone and not wirelessly with everyone else. But more seriously, yes, there's huge personal satisfaction, presumably, and really good augmented reality, but there's also very, very serious applications. I mean, a physician examining a patient, of course, it's been suggested you can, with the augmented reality device, he could actually see simultaneously the patient and say the CAT scan image of the bones and other parts, or a automobile mechanic trying to diagnose a difficult problem. If he looks at the engine and can actually, via AR, actually see the interior of the engine, a rendering of it, that this should be very, very helpful for essentially performing the job he has to perform.
Sure. Oh yeah.
Not at all entertainment. And then finally, I'll take exception to this. Just consider all of the families who have been locked up in their homes this past year. Many of them are fairly affluent, shall we say. My guess is if you offered a really good augmented reality system, a large number of families would have bought such a system for astronomical prices. You can put in your own numbers, but there's potentially a huge market there.
Oh,
So,
for sure, for sure. Yeah, that's all great, exciting stuff. And again, it goes back to, none of that's going to happen unless the fundamental networks are there. And notwithstanding the technical challenges you mentioned about, screen and AR and VR and just the software for rendering in real time in speeds that would make that as a service acceptable. But I think there's going to be some really exciting stuff there. So good. Let's move on a little bit. What? How will 5G affect the implications for cloud native intelligent edge computing? Okay, so maybe talk a little about that.
right. So cloud computing is I think it's important to distinguish between enablers and actually end uses. So no one does IoT for its own sake or even proposes it, or cloud computing for its own sake, or AI for its own sake. It's what you promise you can do with these tools that will basically get people excited and will generate capital and start new businesses. So yes, cloud computing. This of course is not new to 5G. It's been around for some time. It's part of the enhancement afforded by 5G. Just by way of example, yesterday I was doing some brainstorming with a colleague of mine from University of Illinois, Urbana-Champaign. And he told me he had been studying some new type of MIMO intelligent reflective surfaces and was trying out an algorithm using a quantum computer. And I haven't followed quantum computing, so I asked him a bit about this. And he said, well, there's a company that offers this service, a 2,000 qubit computer in the cloud. And so you can actually get time on this computer through the cloud. I mean, amazing. I had no idea quantum computing was that far. That is to say, again, quantum computing per se is not an end in itself. It's an enabler for exciting things.
Absolutely, absolutely. Yeah, so I think I have no doubt that the applications will follow. And yeah, this is the necessary work in advance of those. It's, after all, like how smart would our smartphones be without GPS and without miniaturization of cameras and imaging sensors and silicon and network interfaces. So yeah, fascinating stuff. And what about 5G and artificial intelligence? Can you talk a little about what you see as some real world applications there?
Sure. I mean, of course, AI is one of the hottest topics in every university. Our students are universally fascinated by the thought, and everybody hopes great things coming out of it. Some problems. Well, in my second job, which was in defense industry, I used classical pattern recognition techniques to tackle some problems in radar data analysis, ballistic missile defense, that sort of thing. We didn't have that AI for those sorts of things. But there are just the problem of everybody has seen AI is very good at discriminating between images of cats and dogs. Any child can do that, but it's incredibly difficult to write a reliable computer program to do it. And AI is very good at doing that. So people naturally think there are going to be problems in wireless that are amenable to an AI attack. Just a few general thoughts. at first thought, it appears that the higher layers of the wireless system, where you're trying to schedule resources, you have hundreds or thousands of users all wanting some level of service, you've got a finite amount of resources, you want to optimally use the resources to serve the people who want the service. Now, virtually all of these algorithms are, of the type that, as far as is known, there's no really clever pencil paper solution. You just need brute force. And so this type of problem, an AI attack, I think, has a very good chance of solving. One of my friends at Bell Labs has done work on optical AI techniques for new modulation schemes for optical fiber. So the problem with, optical fiber, of course, we couldn't live without it, but single mode optical fiber, you send actually a rather strong laser beam through a very small portion of the cable, the center part. So the power densities are very high and the glass is driven into a nonlinear regime. And we electrical engineers aren't terribly good solving nonlinear problems. We just don't have very powerful and effective mathematical tools. And so my friend has presented at conferences some rather interesting new optical modulation and demodulation schemes based on AI. So this is good.
Yeah,
Yeah.
fascinating. Yeah, great. I mean, so that's fascinating insights, and those are the kinds of problems that I guess, while AI is evolving independently, again, it's great to see that a technology like that is enhancing a technology like transmission, right, and solving real world problems. And very good. So I'll come back to our scheduled questions a little later, and I do want to finish up with some thoughts on 6G. But what I want to do now is we've gotten a number of questions, and let me throw a few of these at you and see if we can answer some of the questions the audience have. So how dependent are we on China for 5G?
Well, so U.S. carriers, the Verizons, the AT&Ts, Sprints, T-Mobile, are forbidden from buying their base station equipment from Huawei in China. That's the federal rules. So all of our base station infrastructure, or most of it, has to come overseas because we don't have native U.S. manufacturing capability for much of our communication infrastructure. So for base station equipment, for example, the US service providers depend on Ericsson, which is Swedish, and on Nokia, which is Finnish. And this is, Huawei is a large company, a successful one, and there is a concern in many quarters that the West, and in particular the United States, is not working hard enough to maintain a technological edge or even technological parity in this area.
Yeah, that surprised. Well, it doesn't totally surprise me, but it's very disappointing to hear. Is that edge largely the ability to manufacture in the same way that like Intel can manufacture, can not just design but manufacture the silicon? Is it the manufacturing or the design, or is it both?
It's starting to get into the design. So I think hasn't been shown repeatedly in industry that if you give up the manufacturing end and think that you can just do the high level design, eventually the people manufacturing, say, the automobiles or the trucks or the airplanes are going to start to get into the design arena. And because they, of course, can link their research and engineering products to what can be best manufactured, that ultimately will give them an edge over you. And so I think the same thing holds true for communications infrastructure. You can't just hold on to the fundamental research and the nice product engineering and think that you can let somebody else do all the manufacturing, because they'll eventually do everything.
So I guess I know about as much as anybody else on, which isn't a lot probably, on what's going on in the government in order to change this. I'm aware there's a vulnerability there and that we're behind on that. But do you get the sense that the government at the federal level is taking this as a serious threat with 5G, upon us at this point? That or is it sort of another thing we should get to at some stage?
I can't speak for government officials, but I don't think it's getting enough attention. That's a personal opinion, however.
Okay, fair enough. Another question: is 5G signal safe for humans? Any concerns for cancer or other adverse problems?
The answer is, and this is secondhand because I rely on my colleague Ted Rappaport and some of the people he works with at NYU. As far as we know, there's no health hazard. So, again, I haven't worked in that problem myself, so this is hearsay, but I have trusted colleagues who have. And so anybody who wishes further information, just email me and I'll give you the references.
Very good. Very good. Okay, another question. How about teleoperating fleets of semi-autonomous vehicles? Wouldn't that suck up all the 5G bandwidth, or a lot of it at least?
Well, it's of course one of the applications of 5G, robotics, controlling drones. So we have some research in NYU Wireless on controlling drones via 5G wireless networks. Of course, in a control system, a delay is a very difficult thing to deal with. So latency is exceedingly important. Other delays are also, so I think there's great research to be done there. The answer is yes, 5G is actually, this seems like one of the very interesting applications of 5G, right?
Mm-hmm. Okay, and would 5G, I mean, in its current form, would it be capable of, let's say, making some of the decisions that are currently made on board in an autonomous vehicle? Is it of such a reduced latency and capability that maybe not the critical like accident avoidance, but some of the AI, rather than have it in the car, have it in the cloud? Do you see that?
Well, part of the problem is if the drone, and particularly if it's a small drone, has to do all of its own computing and have its own control system, the cost of computation itself requires significant amount of electrical power. And of course, in these vehicles, electrical power is sort of the most precious thing you have, or electrical energy, and it has to be rationed out very carefully. It's a great research area, though. I mean, one's thought, of course, is just to use 5G system as it is. So you have various sensors on board the flying drone, relays it to the opposite end. The opposite end decides on a control law, radios it back. I mean, there are questions. Is digital communication the best thing for utilizing the bandwidth for this particular application? Maybe you should never digitize. Maybe you should just go analog, at least over the communication link, because then you don't have the latency due to channel coding and decoding, for example. So, as I say, great research area because new possibilities are suggested here. And back to the original question, can you overwhelm 5G with huge flocks of drones? Well, I guess it depends how you control the flock of drones. I mean, a flock of hundreds of birds or a V formation of geese don't have any 5G control system. Somehow internally among themselves, they know what to do. And or a school of fish that's trying to escape from a shark.
Mhm.
So I believe, I haven't studied this area, but I believe people are doing research on trying to understand how a flock of drones can sort of control itself like a flock of birds.
Yeah, actually, I did see something on that on a flock of birds where it was actually there was a number, some research done in Italy. There was a like they let's say there were 120 birds in a flying together as a flock. That each group of eight of them, if one of them moved, the surrounding eight moved, and then that little macro move was transmitted to the next group, and that's why they could all appear to the human eye to be in sync. But they actually, yeah. But I think that's fascinating stuff for 5G and 6G and for AI. And it kind of goes back to, I think, the smartphone model where you'll always have some smarts on board locally and some that are remote. But we lost your video, Tom. I'm not sure if you're going to come back, but let's. There you are. You're muted. You're muted. Let's see. Can't hear Tom.
It got automatic. Yeah, I don't know whether I'm having problems with a 4G connection or a 5G connection. I mean, one point I don't think either of us made is that in the end, people want service, and how it's done should be completely oblivious. The user should be oblivious of how things are done. Why do you care whether you're getting your service through Verizon or some other company or through Wi-Fi? It shouldn't matter, except of course if you pay a higher bill for one or the other.
Yeah, absolutely. Okay, so let's move on. We still got plenty of questions. What are the opportunities for 5G to be a last mile technology for internet access to the home?
Oh, that's a good answer. So there's that also it has some relevance on this problem of the digital divide, which is that there are many segments of society that, for one reason or another, simply don't have the same level of communication service that others have. So there are some sections of cities that are not well served by, say, optical fiber, maybe entire buildings that optical fiber has bypassed. Outside of the cities, you get to extreme rural areas, communications can be very poor because, of course, it's expensive to run optical fiber through the ground or copper cable. So people talk about the digital divide. Nothing much has happened there, it seems. So what can you do about it? Well, rural, it seems that millimeter wave line of sight type of service should be almost ideal. It seems that it's probably well understood. It doesn't require digging trenches through the ground. Probably an excellent way to go. So inside of cities, how do you serve people in an entire building, for example? So some of the work a few years ago I was doing on massive MIMO, we were considering having rather large arrays of antennas. I mean, of course, the ultimate limit would be you have a conformal array over the entire face of a skyscraper in New York. And now, what can you do with this? Well, with all these antennas, you could in fact provide, using the midband, say 3 gigahertz, extremely good fixed wireless access service to many thousands or 10,000s of people. So others undoubtedly are thinking of other solutions, but I believe there are things that could be done.
Okay, very good.
Now, of course, if you do think of these skyscraper-sized arrays, there's questions of cost because you're going to be having tens or hundreds of thousands of individual antennas with the attendant circuits. You want, of course, this to be to blend in with the facade of the building. And to be affordable. So all of these represent real challenges for that type of extreme technology. But I think there are things that can be done, again, for this digital divide.
Yeah, and I think that'll probably have to go hand in hand with it because I think 3G and 4G towers look ugly enough as they are on their own. So yeah, but I mean, fortunately, you can put them in areas like industrial areas and so on, but they don't exactly blend in with the natural landscape.
Conformal array, however, you can conceivably make it unobtrusive or even part of a facade. And so, for instance, suburban use of fixed wireless access, we considered these gravity water towers that you see everywhere that provide pressure for the water. They're always the highest part of the whole neighborhood. If you put a conformal array all around that cylinder, you could do tremendous things with it.
Yeah, I mean, that's great. You never even know it's there.
But again, so a lot of new engineering and some research is required to make these extremely large conformal antenna arrays practical.
Yeah, very good. All right, another question. Talking about IoT benefiting from 5G, would you comment on the implementation of 5G in healthcare? I'm concerned as to how fast will my person be hacked, taking my choices over electronically by technology.
Sure. Yeah, we've mentioned previously concerns about privacy, security, even if something gets hacked and some data is altered and a physician prescribes a drug based on falsified or tampered data, that can even get dangerous. So there's a safety issue. And I've not worked in security and secrecy, but it should be apparent to anyone that inherently we have less privacy now than we had 20 or 30 years ago. And some people are more bothered by it than others, but personally, I believe it should be a concern. Now, the measures that 5G is using for ensuring security, in particular when you have medical applications, I'm not knowledgeable enough to comment on. I believe there are measures in place, but you'd have to talk to some experts as to just how secure these measures are considered to be.
Okay, very good. Next question. How do you see 5G playing into the virtual reality enterprise space?
So what does the enterprise space mean? Is enterprise, I suppose, means business type applications?
Yeah, I would say business enterprise. Yeah, large companies and infrastructure.
Yeah, well, as we discussed, there are really serious applications of AR, VR in medicine, people trying to diagnose a difficult problem. Again, somebody who is working on a complicated piece of machinery carries in the head a mental picture of what's inside, but why not give this person an actual AR type of image of the interior of the device superimposed on what he's actually seeing.
Okay. Do you know if enterprises in general in the commercial space are actively looking for applications, business applications of 5G?
I'm sure of it, but I'm not following that line very closely enough to comment further.
Okay, very good. This is kind of related to the earlier question on China. It's a little different though. How do we compare with China at this point and the foreseeable future regarding 5G technologies? How are we doing in that race?
Well, so how do you measure this? One of the measures of your mastery of technology is how many, what are they called? They're called standard essential inventions do you have? So underlying all wireless standards are a set of essential patents that exist, and they belong to one or the other parties, and all of this tends to get pulled together in some manner, um, trading back and forth and so on. But again, all wireless standards, for example, are underlined by essential patents. And now if you look at the essential patents underlying 5G, most of them did not originate in the United States. I don't have the figures, but a significant number come from China. So this is certainly an objective indicator of one of the objective indicators of what's really going on.
Okay. I mean, one, like as a reference point for that, are you familiar enough with, let's say, the developments at Huawei and how they would stack up against, let's say, Ericsson and Nokia that you mentioned earlier? I mean, I'm familiar with all three companies, but not enough to know, like at a deep level, how advanced they are compared to each other.
Yeah, I don't know that either. That's, obviously each company wants, of course, to tell its customers that it's the leader, and it's probably very difficult to get objective measures for if
Sounds,
don't belong
yeah.
to any of those companies.
It sounds to me like we need to resurrect Bell Labs, but then you and I are both kind of partial to that, being that we work there. Yeah.
Well, again, I believe that, I mean, looking ahead to what 6G may require 8 or 10 years from now, if one really thinks you're going to have to be able to do things like mobile AR with all of the huge throughput and requirements attendant with that, uh, I don't think we can do it with today's technology. But the answer is, I don't think we have any ready technology for that waiting in the wings. So in a sense, so 10 years ago, when 4G was being introduced and people were starting to think of 5G, we had two physical layer technologies waiting in the wings, so to speak. Ted Rappaport was already talking about a mobile millimeter wave, doing experiments, starting to show that this actually was a feasible thing to do. Many thought otherwise. And I had been talking about massive MIMO already for at least 5 years, 10 years ago. We don't have anything that seems as certain of success as those two items right now. So in one sense, then, we're actually farther behind now in wireless R&D and good ideas to start to develop than we were 10 years ago. And I think part of that is wireless fundamental research has been neglected to a great extent in recent years.
Okay. All right. Very good. So there's two questions here that I'm going to kind of combine, and they go back to an earlier topic, which is health. And so let me just read at least part of this. We live in a time of conspiracy theories, and one that a lot of folks have heard about is how dangerous 5G is going to be for human health. And a lot of us realize that a lot of these are they're not well-founded theories, or they're conspiracy theories, I guess. The second question was, again, we kind of answered it earlier, but let's just kind of go back to it a bit. Concerns with millimeter focus cone of 5G. So can you say a few words? I mean, yeah, that whatever studies have been done, and I'm sure it's out there for folks to see from reputable sources. But what are your thoughts on what would you say to such theories as far as debunking them goes? What's the strongest argument against them?
Again, I don't want to speak off the cuff of that on that topic. If one of the listeners wants to send me an email, I'm easily found, and then I'll be happy to suggest references. But I think I'm going to leave it at that because,
Yeah.
again, I haven't personally studied that problem, and I've been happy to leave it to more expert people.
Yeah, no, that's fair enough, I think.
But at the same time, I do agree that if the public hears that there may be some health hazard, then the public may, or some segment of the public may say, well, prove to me absolutely that this is safe, that it can't cause damage. And of course, it's very difficult to prove absolutely that something can't cause any damage at all.
True.
But you have to live. We take risks all the time, and so I don't know. I don't have a good answer, I think.
Oh, and I think
But all of the physiology, my understanding is that millimeter waves can heat up the skin, but that's the primary action if it's sufficiently high intensity. Now, if you're 50 meters from a cell tower, that isn't going to happen. And I seem to recall Professor Rappaport saying that as you go up to another factor of 10 in frequency, up to a few hundred gigahertz, in fact, the body actually becomes a very good reflector of terahertz waves. And so even less opportunity for mischief.
Oh,
so
I never knew that.
it isn't until you get up to, and so you have to go up, let's see, so you have to go up to several hundred terahertz before you get to optical wavelengths. And then when you start to go beyond optical wavelengths, then you start to hit ultraviolet and further on ionizing radiation.
Right.
But we're basically we're talking about a factor of several thousand away from that regime in frequency.
Yeah, that's a good point. And I guess it's kind of like when the X-rays and MRIs were introduced. I think the public in general, it's like anything. The beauty is you've got the internet out there, and if you search wisely and you look for reputable sources, and if you're really concerned, you talk to your own physician and ask them for references. I think you'll find a prudent answer. You'll find the best answer you can find at this time, I think. Let's put it that way.
Well, when Marconi first was doing his experiments with radio 110, 120 years ago, some individuals were complaining of discomfort from this new form of electromagnetic radiation that Marconi was creating. But of course, we know that this could not possibly be possible. He was operating at wavelengths of hundreds of meters, and just not the case.
Right. Or and also, like, look at alternating current. When Edison invented direct current, and then Tesla came along with AC, that was the big scare, was that can kill you, and indeed it can. But it hasn't stopped us from wiring our homes and powering our lives with it. So there's a prudent course, and there's a middle road, and there's I think a prudent use of technology, and just plain common sense.
That's right.
It's
risk management, risk assessment. There's
right.
Almost anything you do has some risk associated with it, and in the end, somebody has to calculate relative risks and advantages and gain and cost, and do some sort of optimization that results in a decision.
Exactly, exactly. We only got a couple of questions left here, and I want to kind of leave some time for the future and 6G. Um, let's see. How are the airwaves owned and licensed in other countries? Are there legal ownership issues when transferring developed transmission technology?
I think this always has to be considered because yes, different countries do have different regulations. Uh, one of the difficulties in 5G in the United States is that a large swath of the mid-band, 1 gigahertz to 6 gigahertz, say, is controlled by the U.S. Armed Forces, and apparently less, relatively speaking, in many other countries. And so this midband is incredibly good spectrum because it's not blocked by foliage or the human body. It can go into buildings. There are other advantages. And just an example, though, of national policy at work.
Right. Okay. Um, and So let's see, what are your thoughts in general then? Let's say if we step back, and look at the technology, we know where it is today. We've discussed like what could be some great applications in the future. We've also discussed about, this is sort of laying the groundwork for as an enabling technology for other technologies and so forth. What would you say for you? What is the most exciting thing that you see ahead? Let's say, and whether it's maybe within the next 5 years, and then with let's say after that 6G and beyond.
Oh, wow. So would this be what with respect to applications or?
Yeah, yeah. Let's say, what do you see as let's assume that all the good engineering gets done and that the carriers and the money's put into the networks and the networks are built and those 64 by 64 arrays, are throughout, and we find ways to make it like the facade of a building or a water tower, as you mentioned, and so forth. And we get past all of that and the network's there and it's available at the speeds that you and your colleagues envision. It has reached the true potential of 5G. And let's say the first question is, and at the point where you would then say, okay, you're turning it over to the production and distribution and manufacturing now, and you'll move on to 6G. So what do you see in that time frame where 5G is out there and it's reached that point of maturity? What do you think would be some of the exciting applications or some of the exciting things you could do with it?
With 5G in its mature
Yeah, 5G, let's say first.
again, that's very difficult to say. It's going to, you know, uh, I don't yet see any such thing. In other words, it's not that I'm not enthusiastic about the future, but
Or maybe there's an area, is there an area that you see as ripe for 5G? An industry, a technology sector, whether it's IoT or autonomous vehicles or medical, agriculture, smart cities?
well, that's really again, that's I don't think I can envision. I don't think that I have sufficient confidence in any particular exciting thing cropping up, say in the next 5 years on that. I don't want to sound pessimistic, but my own research is trying to look at things beyond that. So, I mean, the human brain has 10 to the 11 neurons. And by the way, when I was an undergraduate, I took a couple of courses in psychology of perception. In those days, they said we had 10 to the 10 neurons. And so somehow we've gotten 10 times smarter since then by neurons. But people have dreamed of, can you actually communicate directly with the human brain? And so now this raises a fantastic question in near field communications. So people have developed some experimental devices that can actually transmit information from 100 neurons to an exterior wireless receiver. Okay, but that's of course a factor of what, 10 to the 9 away from what's there. And so this whole problem of extremely high data rate near field communications is something totally untouched by communication theorists, but there are obvious incredible things to dream about. I think one of the difficulties is that, again, we need applications people with a lot of imagination, and the more imagination they have, the more problems they're going to, interesting research problems that we're going to have to solve, and entire new industries are going to get formed based on these visionary ideas.
Right.
But it's just a little difficult to get real excited about a wristwatch that can measure my pulse or blood pressure at all times. I mean, yes, this can be useful if you have certain patients who wear a long-term recording of these vital signs as a function of activity or diet or other things was recorded. That could be very valuable, but routinely, it's difficult for me to get excited about things like that.
Yeah. Well, then what would you like to see happen? Do you see, let's say in the technology itself, millimeter wave just continue, to be able to increase the bandwidth? Or do you see the technology advancing more on, you had mentioned like 64, an array of 64 transmitter receivers. Will that go to
Well,
128?
those have been made for several years now. All of the vendors sell those. They're amazing devices, very compact like that, maybe 25 or 50 kilograms, weatherproof, amazing stuff. But again, back to applications. So we're just going to have to see, I think, again, 5G and drones and robots, these are going to happen. The question is, for the average person, what effect is that going to have? I mean, the person's pizza might be delivered from Domino's by a flying drone. Yes, this is different. Is this transformative, however? I don't think this is nearly as transformative as the initial step of getting mobile telephony, which we've had, for 20, 25 years now, right?
Right.
So I really would like to see more imagination put into applications. Now, of course, there's huge benefit in solving more routine application problems, huge demand for it. But are these going to be transformative things for the average person? That's something that's the question I put on the table.
Okay, very good. And I think, yeah, it's sort of like the fundamental research that you're doing and NYU is doing, is again, that they're like the enabling technologies. That to me, they're like the GPS, and the vision systems and the speech technologies that, when packaged together, they do something that, the retail market really wants to buy. But I think that's up to private enterprise, and as you mentioned earlier, the imagination of individual entrepreneurs or entrepreneurs or imaginative individuals at large companies that come up with these applications once they see that they have access to that technology.
I mean, GPS is a great example that you just mentioned. I mean, this was initially conceived, I guess, in the 1970s, approximately, as a military guidance system, and it was only after it was introduced and civilians wanted to start to use it that, of course, it became a huge civilian application, and now most people don't bother with paper maps now. They rely on GPS. There's a lot to say for that. And it's been transformative, definitely.
Yeah.
And of course, you couldn't operate drones, probably navigate them so nicely if you didn't have GPS.
True, true. Yeah, so many of those, fundamental technologies that enable others, and then the applications come along later.
So I do think that you will see some exciting applications like GPS, but they emerging enabled by 5G. But I can't suggest what they are at the moment.
Yeah, yeah. That's fair enough. That's fair enough.
Which, of course, if I could, well, this would be remarkable ability to predict the future, and one could invest accordingly. But I don't have that ability.
Yeah, true. It would be it'd be like having the crystal ball, and basically knowing where to go with the technology. But I have no doubt that'll come about. Um, I did get another question here. And maybe, I want to spend the last little bit of time we have talking about what NYU is doing. But the question is, does MIT or NYU work with local entrepreneurs and startups to assist in innovating end uses for technologies such as 5G?
I
So,
believe the answer is yes, but I'm not closely attuned to that. I haven't participated in that process. But NYU does have an organization for incubating that type of startup idea. Yeah.
yeah, I'm familiar with that too. There are a number of labs. I think the Future Labs, and there are
That's
some
it.
of them there.
Future Labs. Yes,
Right,
thank you.
right. And yeah, and so absolutely. So anyone that's interested, you can definitely look into NYU on that, and I'm sure MIT also does. But yeah, many of the great universities now, I think, have embraced, as separate from 5G, but they've just embraced entrepreneurship and the startup ecosystem and communities. And New York is one of the best places, I think, in the world for that right now, with the resurgence of technology in and around the New York City area. And of course, NYU is right in the heart of that. Can you just talk a little bit about what NYU is doing in the wireless lab, in the labs that you have? Are you specifically focusing on specific areas now?
So we cover all aspects of wireless, from the physical layer to the applications. So we have 6 research thrust areas. I don't think I want to go into all of them, but one of them is millimeter wave and terahertz. So this consists of fundamental propagation measurements, both indoors and outdoors. Important stuff because, again, people have the same questions about terahertz that they had 10 years ago about millimeter wave, and those need answering. We have circuits people looking at new types of semiconductor devices. You go up to hundreds of gigahertz. You have to, with current technology, work very hard to generate significant power. So we have people looking for breakthroughs there. We have people looking at the edge computing and low latency techniques in wireless networking. Applications. So we have robotics people who are looking at 5G control of robots. An interesting project is new types of image coding. Image coding is designed, of course, to send as few bits as possible, but give you a high quality picture nonetheless that's pleasing to the eye. But supposing instead of a human viewing the pretty picture, you actually want to send this to a AI machine, for example, or machine learning algorithm to make some inferences from the image. Well, then it seems reasonable that you should do this encoding, this compression of the data according to a different criterion, because you don't care if the image at the other end looks pretty or not. You care whether or not the AI algorithm is able to make the most accurate inferences. So this is a really a nice fusion of several topics at once. We have some test bed projects. So there's this Power Cosmos project funded in part by NSF, which is basically a citywide 5G test bed in New York City. And so a number of universities are involved with that. And the whole idea is actually to do experiments on a live 5G wireless network. And then finally, there's the area that I tend to concentrate in, which is fundamentals of wireless communication. There, it turns out that no existing wireless system operates anywhere near any limits that are imposed by nature. So we're very far away from any fundamental limitations in terms of wireless. It's just that we don't know how to do it right now. And that's where I think some concerted efforts might result in some breakthroughs. Another thing that I'm interested in is wireless power transfer. So just think if instead of a drone carrying a heavy battery, which is of course the ultimate limitation of any drone, supposing you could just beam up power directly to it wirelessly, that would be a huge new thing. But these concepts are going to require a lot of fundamental research.
Is that physically possible, though, that you can?
So in 1943, a Bell Labs researcher, Shelkonoff, who's best known for developing the coaxial cable, Shelkonoff wrote a paper where he discovered a phenomenon which is now called super-directive antenna arrays. Basically, the idea is an antenna array which is not very big could in principle direct an arbitrarily fine beam. And the mathematical principles are understood, but nobody has made this happen practically. Now, on a very small scale, people have used this concept to their advantage, but can something practical come out of this? Some people say no. I'm one of the optimists, and so that's why I'm investing some effort into that.
Great. Sounds great. Sounds like there's a lot of exciting work to be done ahead. And it sounds like, this was a very timely event for the state that 5G is in. I think the takeaways are that, the 5G community is continuing to build 5G as a fundamental enabling technology upon which many of the sort of parallel developments in AI and IoT and cloud and machine learning and AR and VR can all leverage when we arrive with those applications. But I think this is all part of the natural evolution of technology and how it goes. You develop the fundamental technologies, you put them out there, and then you see what as you mentioned earlier, Tom, the imaginations of the either the individual entrepreneurs or the companies come up with in ways they did for the smartphone, leveraging the vision and imaging and GPS and so forth, accelerometers and so forth. So all right, I think we've answered all the questions and we're just about at the end of our time here. So I wanted to thank you for participating today, Tom. It's been really great to have you, and I've really enjoyed our conversation. It's been a pleasure, and I really appreciate it on behalf of MIT Enterprise Forum.
Well, thank you, Dan. It's been a privilege being here. And I guess the final thing I want to say is that there's a huge range of opinion in the wireless community about what the future is going to be like. And so you talk to 10 people, you're likely to get 10 different opinions. So you've gotten one opinion from, or a number of opinions from one person today. But to talk to some other people, even at NYU, you'll get some different opinions.
Well, one thing's for sure, I think they'd all agree it's definitely going to be exciting.
Indeed, that it will be.
Yes. Okay. Well, thanks again, Tom. Really appreciate it. And thanks everybody for attending. Bye-bye.
Goodbye now. Thank you.